Welcome back everyone. So in this session we are going to find out the LCM and HCF using prime factorization. And what is prime factorization? Let's see once. See, as you know, what are prime numbers? Prime numbers are the number which are divisible by none other number than 1 and itself. For example, this 2, 3, 5, 7 and then 11, 13 and so on, they all are prime numbers. They all are prime numbers. And rest of the numbers excluding 1 are composite numbers. 1 is neither prime nor composite number. Now, I told you about what is prime number. Now, we will be talking about factorization. Factorization we discussed in number systems as well, but let's discuss here also. For example, there is this number 36 and you want to factorize this number. So you have to check what are the numbers will be dividing 36. For example, 2 will be obviously dividing 36. Let's start with 1 only. 1 will be dividing 36, then 2 will be dividing 36, then 3 will be dividing 36, 4 will also be dividing, 5 will not divide 36, 6 will be dividing 36, then 7, 8, 9, 9 4s are 36, 10, 11, 12, 3s are 36, then 13, 14, 15, 16, 17, 18 and 18 2s are 36 and 36 1s are 36. So these are the numbers which are going to divide 36. They are the factors of 36. I hope this makes sense to you, right? These are the numbers are factors of 36. Now, if I talk about prime factorization, coming to the topic as prime factorization, what is prime factorization? For example, if I want to express 36 in prime factors, then what would be the prime factors of it? So factors are the number which divides the given number completely. So if I say what are the prime factors of 36, right? What are the prime factors of 36? So prime factors are, see, this 2 is the prime number, 3 is the prime number, then only 2 and 3 are the prime factors, right? But if I talk about prime factorization, then I am saying how many times if I take 2 and 3 and it makes up 36, right? For example, I know 36 is what? 9 into 4. 9 is nothing but 3 square and 4 is nothing but 2 square. So if I multiply 2 square into 3 square, then it will become 36, and that's how prime factorization is done. So if I talk about, let's take one more example for the sake of simplicity. Let's take 48, and I know 48 is what? Let's list out all the factors of 48. 48, 1, 2, 3, then 4, 5 will not be divisible. 6 obviously it is divisible by 2 and 3, then it will be divisible by 6, then 7, then 8, 8 6 are, right? Then 9, 10, 11, 12, yes, 12 also, then 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 and then 24 and then 48. These are the factors of 48, right? But what are the prime factors out of it? Prime factors are nothing but again 2 and 3 only, because see, this is a prime number, this is a prime number. Nothing number else is a prime one, right? Now if I talk about prime factorization, then prime factorization will what? See, you have to just simply think of two numbers which can result up to 48. So 48 is what? 16 threes are. Let's take one example. 16 threes are 48. So 16 can be written as 2 to the power 4, and then 3 can be written as 3 to the power 1. So this will be the prime factorization of 2 to the power 4 into 3 to the power 1. Now, that's how I can express any number in the form of prime factorization, and that's how I can do prime factorization, right? So see, you have to just focus on one rule and one observation, rather I say, that any number, for example this 36, we have the prime factorization as 2 to the power 2 into 3 to the power 2. We have 48, the prime factorization is 2 to the power 4 and 3 to the power 1. This prime factorization is always unique. This prime factorization is always unique for the given number. For example, that means that 2 to the power 2 into 3 to the power 2 cannot be the prime factorization of any other number except 36, right? Similarly, 2 to the power 4 into 3 to the power 1 cannot be a prime factorization of any other number than 48. This is the basic principle, fundamental principle of arithmetic, right? Now, will drive the concept of LCM and HCF using this prime factorization, and that is way more easier than any other method, right? Now, before proceeding to how to find LCM and HCF using prime factorization, let's just firstly understand what is LCM and what is HCF. See, as the definition says, HCF is highest common factor. HCF is highest common factor, and LCM is least common multiple. LCM is least common multiple. So as you know, there is this prominently one term that is, difference. This is the major difference between the two, that is multiple and factor, right? These two terms I have already described you in the introduction video, what is factor and what is multiple, right? Now let's try to focus on highest common factor and least common multiple, right? Now let's say I am taking one example, that is 24 and 36, right? There are two numbers, 24 and 36, and I'll be firstly writing their factors. I'll be writing their factors. So if I write the factors of 24, so that would be 1, 2, 3, 4, and then 6, and 7, 8 will be the factor, then 9, 10, 11, 12 and 24. These are the factors of 24. I hope it is making sense to you. What about 36? We will be having similar kind of factors for 36 as well. 4, 5 will be not, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18 and then 36. They will be the factors of 12 and 36. Now, as you can see, if I talk about factor only, right? So what you can see exactly is the highest common factor between them. So highest common factor is, see, 1 is also a common factor, 2 is also, because 2 will also be here, right? 2 is also a common factor, 3 is also a common factor, 4 is also a common factor, 6 is also a common factor, 8 is also a common factor. But which one of these is the highest common factor? The highest common factor is 12, right? So 12 will be the HCF of 24 and 36, right? I hope it is making sense. Similarly, let's try to find out the multiples of 24 and 36. So if I write 24 and 36 and if I write multiples, right? So 24 into 1 is 20, this will be the first multiple, this will be the second multiple, this will be the third multiple, and so on, right? So 36, 24 ones are 24, 24 twos are 48, 24 threes are 72, 24 fours are 96, and so on, right? What about 36? Can you recall the multiples of 36? So 36 ones are 36, 36 twos are 72, 36 threes are 108, and 36 fours are 144, and so on. This goes on, right? Now you have to find out least common multiple. See, if I talk about the first multiple that is common between these two is nothing but this 72. 72 is a number which is common between 36 and 24. So here 72 will be the LCM of 24 and 36. I hope it is making sense to you, right? Now let's try to find out the HCF. What we get as 12 will be the HCF of 24 and 36, and here 72 will be the LCM of 24 and 36. We'll try to find out these LCM and HCF using prime factorization. So how do we do that? Let's understand. Now as we discussed, we took two numbers 24 and 36. We found their HCF as, we found the HCF as 12 and LCM was 72, right? This was the thing that we got using the, without doing much calculation, just by going straight away with the definition, right? Now we'll try to do find out these numbers using prime factorization only, right? So there is this number 24 and there is this number 36. If I write the prime factorization of, this is what, 8 into 3. So 8 is what, 2 cross 2 cross 2 into 3, and 36 is what, 4 nines are, that is 4 is what, 2 into 2, and 9 is what, 3 into 3. So this will be nothing but, this will be the prime factorization of 24. Now if you want to find out the HCF, just pay your utmost attention over here. If you want to find out the HCF, you have to take out the common factors. First of all, this 2 will be common out, and then 3 will be common out, and then this 3 will be common out. So what will be 2 into 2 into 3? This will result in 2 2s are 4, 3s are 12. This will be your HCF. And if you want to find out the LCM, all you need to do is, you have already taken down the common terms. So 2 into 2 into 3 are the common terms, and what is remaining over here? This 2 is remaining and this 3 is remaining. So you will write them down as it is, 2 into 3. What I will be getting is 2 2s are 4, 3s are 12, 2s are 24, 3s are 72. And that's how you can find out the LCM and HCF of any given number using the prime factors. Let's try one more example, and that we'll try to do it quickly. For example, there are two numbers, that is 16 and 24. Let's take a smaller number only, or let's take one more number, that is 30, right? 16, 24 and 30. And firstly you have to find out the HCF, and then you have to find out the LCM. So I would suggest pause the video and give it a try, and then we'll solve the question. So I hope you have solved this question. So let's try to do it. So firstly, in the first step, we'll be doing the prime factorization. So 16 is 2 to the power 4. Again 24 is what? 8 3s are 2 into 2 into 2 into 3. And 36 is what? Oh sorry, 30 is what? 5 6s are. So 5 is what? 5 is what? 5. And 30 is what? 2 into 3 into 5. 6 into 5, 6 is what? 2 into 3, right? Now, as I said, HCF is the common thing between the all three. So, here is one common thing, that is 2. And again common thing, there is nothing else common between the two. So, the HCF will be 2 only, right? And LCM will be what? You have to take out all the common things first of all. So, this 2 I have taken, then again there is this 2, so that I will take out once, then again there is this 2, that also I will take out once, and then there is 3, this is common between the 2, so that I will also again list out. There is 1 2 remaining, there is 1 5 remaining, so 2 into 5, so that I will be getting at as 2 2s are 4, 8, 24, 24 2s are 48, 48 5s are 48 5s are 5 200 and 240, right? So that is the LCM of the given number. There are more other ways of finding LCM also, that is long division as well. But again I would suggest, if your basics are pretty much clear. So for example, you just need to have a look. See, 16, you have to find such a number in which all of those given number are, involved in some or other way. So what I am trying to say is, see, in 16 there are 4 2s, right? In 24 there are 3 2s and a 3. So if I divide 16 into 3, if I multiplied 16 by 3, then the least common multiple between the two I will be getting, that is 48. 48 is the number which is divisible by both of the number, right? And then 30, here I come 30, 30 is what? 30 contains 5, 3 and 2. 2 and 3 already I have counted, right? In earlier case there are plenty of 2s and plenty of 3s. What I am remaining with is 5. So if I multiply 48 by 5, I will be getting this number, and that is the nothing but the LCM of the given number. So that's how I can find any of the LCM and HCF using prime factorization. I hope this is clear to you. We'll solve more questions in your dashboard practice section. Please solve those questions so that you get more hold on the HCF and HCF. In the coming video, we are going to discuss some more important applications of HCF and LCM, right? See you in the next class. Thank you so much.